Good afternoon everyone. My name is Sachin Chaudhary and today we are going to learn a very important topic from the unit of chemical bonding, that is Vsepr theory, means valence shell electron pair repulsion theory. So these are the content of my today's topic. In order to explain the shape of a molecule, a simple qualitative theory was proposed by Sidgwick and Powell in the year of 1947, and this theory was modified by Gillespie in the year of 1957. So generally the Vsepr theory is based on the interaction of electron on the valence shell of central atom, and so name is valence shell electron pair repulsion theory. So this theory explains how the 3D shape of molecule is formed, how bonding and non-bonding electron pair repel each other, and how these repulsion result into a shape of a molecule. So before we start predicting the shape of molecule, first we will see some basic rule of Vsepr theory. So the first rule of Vsepr theory is that the electron pair, that is bond pair and lone pair, always try to stay as far apart as possible to minimize the repulsion between them. Then the second rule, that is steric number. So steric number is useful for calculating the number of electron pair, that is bond pair and lone pair. So steric number is the sum of lone pair and bond pair, and the number of electron pair on central atom is calculated by using this formula, that is Z is equal to 1 by 2 number of valence electron on central atom plus any negative charge on molecule minus any positive charge on molecule plus number of monovalent atom attached. So monovalent atom means ऐसे एटम जिस एटम की वैलेंसी 1 होती है, जैसे हमारे पास हाइड्रोजन है, हाइड्रोजन ग्रुप, इन एटम की वैलेंसी 1 है, इसलिए इन एटम को मोनोवैलेंट एटम कहते हैं. सो बाय यूजिंग दिस फार्मूला वी कैन इजीली कैलकुलेटिंग द नंबर ऑफ इलेक्ट्रॉन पेयर ऑन सेंट्रल एटम, and by using this we can easily predict the shape of a molecule. This third rule is, if lone pair of an electron on central atom is 0, then the geometry of molecule is shape of molecule, and if lone pair are present on central atom, then geometry is different from shape of molecule. Then fourth rule is, generally the lone pair of electron on central atom occupy more space. So due to that the repulsion between the lone pair is more, and that's why the repulsion, we see the repulsion order in Vsepr theory while predicting the shape of molecule is the lone pair repulsion is more than bond pair, lone pair is greater than bond pair. Then fifth rule is, if the central atom is electronegative atom, then it pulls the bonded electron pair toward itself and causes the more repulsion, and hence the bond angle increases. For example, in NH3 and PH3 molecule, both the molecules have same geometry and same shape, but due to presence of electronegative atom in ammonia molecule, that is N is more electronegative than phosphorus. Due to that, the bond angle between in NH3 molecule, that is HNS bond angle is 107, and in PH3 the bond angle between the bonded pair is 93. So in case of NH3 bond angle is more compared to PH3. Then the next rule is, multiple bond does not alter the geometry of molecule. For example, in BeCl2 molecule and in CO2 molecule. So in BeCl2 molecule, both the Cl atom are singly bonded to the beryllium atom, and in CO2 molecule both the oxygen atom are doubly bonded to carbon atom till the geometry of molecule is same, that is linear. So means multiple bond does not affect the geometry of molecule. Then last rule is, repulsion is more if bonded pair are at 90 degree and sharply decreases with increasing bond angle. Then Vsepr notation. In Vsepr theory, while predicting the shape of molecule, we use simple notation, that is A, X, M, E, N, where A is central atom, X is a bond pair of number of bond pair of electron, and E, N is a number of lone pair of electron. So if the steric number is 2, then the Vsepr, we use Vsepr notation, that is AX2. Means in this molecule the bond pair are 2 and lone pair is 0. So the geometry of molecule is linear, and also shape of molecule is linear, because there is no lone pair present on this molecule. So the bond angle is 180 degree in linear shape geometry, and a very good example is BeF2. Then if the steric number has value 3, then we have see two cases. First is AX3 type and second is AX2E1 type. In AX3 molecule, all the electron pair are bonded pair, there is no lone pair of electron, and hence due to presence of 3 bonded pair on central atom, the molecule shows trigonal planar geometry, and shape is also trigonal planar, because there is no lone pair of electron present on central atom, and the bond angle between the bonded pair is 120 degree, and the example is BF3. Then second case in steric number 3 is AX2E1. Here the bond pair number of bond pair are 2 and number of lone pair of electron is 1. So no doubt the molecule has same geometry, that is trigonal planar, but due to presence of one lone pair of electron, the molecule has bend shape, and the bond angle between the bonded pair, that is less than 120 degree, and the example is SO2. So due to presence in this molecule, due to presence of one lone pair of electron, the repulsion between electron bond pair and lone pair is more compared to bond pair, and that's why the bond angle gets compressed and comes to less than 120 degree. Then if the value of Z is 4, then we have to see 3 cases, that is AX4, AX3E1, AX2E2. So in first case, all the electron pair are bonded pair, and the molecule shows the tetrahedral geometry, and the bond angle between the bonded pair is 109 degree, and the example is CS4. In second case, that is AX3E1, in this molecule the bonded pair are 3 and lone pair of electron is 1. So the molecule shows tetrahedral geometry, but the shape of molecule is different from the geometry, because due to presence of one lone pair of electron, the molecule shows pyramidal shape, and the bond angle, here the bond angle is less than 109 degree. Then third case, AX2E2. In this molecule, the number of bond pair are 2, also number of lone pair are 2. Then the molecule shows tetrahedral geometry, but due to presence of 2 lone pair of electron, the repulsion between lone pair is maximum. The molecule shows bend shape or angular shape, and the bond angle between the molecule is 104. Then next is, if Z has value 5, then we have C 4 cases, that is in first case X5. In this molecule, all the electron pair are bonded pair, and the molecule shows trigonal bipyramidal geometry, and the bond angle between the bonded pair are 90 degree and 120 degree. Then second case AX4 E1. In this molecule, out of 5 electron pair, 4 electron pair are bond pair and 1 electron pair is lone pair. So due to presence of one lone pair of electron, the molecule has no doubt trigonal bipyramidal shape, but the shape of molecule is seesaw, and location of lone pair of electron occupy equatorial position, because in equatorial position has low repulsion compared to axial position. Then third case is AX3E2. In this molecule contain 3 electron pair, bond pair and 2 lone pair. So due to presence of 2 lone pair, the molecule shows same tetrahedral bipyramidal geometry, but the shape of molecule is T shape. So due to presence of two lone pair, the bond angle is less than 120 degree and the molecule shows T shape. Then last case is AX2E3. In this molecule, the molecule have two bond pair and three lone pair of electron. Then the molecule shows trigonal bipyramidal geometry, but the shape of molecule is different from the geometry, that is linear shape, and the bond angle is 180 degree. And the example is XeF2. If the value of Z is 6, we have seen also 4 cases. In first case, AX6 means all the electron pair are bonded pair and the molecule shows octahedral geometry. Then next AX5E1. AX5E1 molecule have 5 bond pair and 1 lone pair, and due to presence of 1 lone pair of electron, the molecule shows square pyramidal shape. And second is AX5E2. Due to presence of 2 lone pair and 4 bond pair, the molecule shows square planar shape and the geometry is bipyramidal. In this way, we can easily predicting the geometry as well as shape of molecule depending on the value of Z and also the number of bond pair and lone pair present on molecule. Then next is, so this is the calculation of bond pair and lone pair of predicting the shape of molecule. So for example, in NH3 molecule, so how to calculate the bond pair? So in NH3 molecule, the central atom is nitrogen. Nitrogen have 7 atomic number, and the electronic configuration of nitrogen is 1s2, 2s2 and 2p3. So the valence shell of nitrogen is this second orbital. So in second orbital there are 5 electrons, means valence electron and nitrogen atom are 5. So by using this formula we can, and the number of bonded pair are 3. Monovalent atom are attached in NH3 molecule are 3. So by using this formula we can calculate the value of Z, and the value of Z comes to 4. Out of 4 electron pair, 3 electron pair are bonded pair and 1 electron pair is lone pair. So due to value of steric number is Z is equal to 4, the molecule shows tetrahedral geometry and the shape of molecule is pyramidal. So in this way we can calculate the number of electron pair on central atom and predict the shape of molecule. Then application of Vsepr theory. So these are some molecule with only bond pair of electron present on the molecule. So in this linear geometry, the central atom are bonded to 2 atom, that is in BF2 or CO2. In this type, the bond angle between the bonded pair are 180 degree and the molecule have same shape as well as same geometry, that is the molecule shows linear geometry as well as linear shape. Then next is trigonal planar molecule. So in this molecule 3 atoms attached are bonded to the central atom, and due to 0 lone pair of electron present on central atom, the molecule shows trigonal planar geometry as well as shape of molecule is also trigonal planar. Then next is AX4 type. In AX4 type, the example is CH4. In this molecule, all the electron pair are bonded pair and the molecule shows tetrahedral geometry and the shape of molecule is also tetrahedral. Then trigonal bipyramidal. In this type AX5, all the electron pair are bonded pair. The molecule shows trigonal bipyramidal geometry and the shape of molecule is also trigonal bipyramidal due to no lone pair of electron on central atom. And the angle between the bonded pair are 90 degree and 120 degree. In axial position, the bond angle between the axial and equatorial position is 90 degree, and in equatorial position only the bond angle is 120 degree. The next is octahedral. In octahedral type of geometry, The type is AX6. All the electron pair are bond pair, and example is SF6. So by using that formula, we can easily calculate the steric number of this molecule. Once the steric number is calculated, then we can easily predict the shape of molecule. So in this molecule, all the bonded pair are at 90 degrees. Then these are some example, the molecule which contain bond pair as well as lone pair in NH3 molecule. We see the example of NH3 molecule. In NH3 molecule, out of the steric number of molecule is 4. Out of 4 electron pair, 3 electron pair are bond pair and 2 electron pair are lone pair. So due to that, the molecule has tetrahedral geometry and the shape of molecule is pyramidal. And the bond angle between the bonded pair is 107. Then next is the molecule which contain 2 bond pair and 2 lone pair, means AX2 E2 type. So in this molecule, the steric number of molecule comes to 4, and out of 4, 2 are bond pair and 2 are lone pair. Due to presence of 2 lone pair, the molecule has V shape, and the angle between the bonded pair are 104 degree, and the molecule shows tetrahedral geometry, but the shape of molecule is bent shape due to presence of 2 lone pair of electron. So this is the Vsepr geometry of some molecule. So in this molecule, presence of 1 lone pair, and also for predicting the geometry, we consider bond pair as well as lone pair. In this, we consider lone pair as well as bond pair. So the molecule shows trigonal planar geometry. But for predicting the shape of molecule, we consider only the bonded pair, not lone pair. That's why the molecule shows V shape or angular shape. So in this way, we see the Vsepr theory, and last is the limitation of Vsepr theory. So first limitation of Vsepr theory, it predict the shape of only S block or P block or group 13 element. It does not predict the shape of transition metal. Then second limitation of Vsepr theory is this model does not take to relative size of substituent, means इसमें साइज का कुछ एक्सप्लेनेशन नहीं दिया है. जैसे अगर एखादा बल्की ग्रुप अगर हमारे सेंट्रल एटम पे अटैच होगा, तब रिपल्सन बिटवीन द बल्की ग्रुप कॉज मोर रिपल्सन. सो इसके बारे में Vsepr theory में कुछ भी नहीं बताया है. And the last example is this theory unable to explain atomic orbital overlap. Means in case of hybridization, we see the atomic orbital overlap, that is sp3, the overlapping between s orbital with sp3 orbital. But in this theory, it doesn't explain any overlap between atomic orbital. So this is all about Vsepr theory. Thank you.